it in other frameworks, okay? But look, it's what it is. So in Fastify, we have a tiny utility called Under Pressure that manages all of this stuff. It also manages the event loop delay, utilization, memory, and so on and so forth. Okay, and you can use it to protect your application from this kind of attacks, or just if your app went viral and you're screwed. Okay, so it is what it happens if you use Under Pressure. Okay, if three requests comes in, okay, it is the same model that we did before, right? However, we can detect that the event loop utilization is our server is busy, and what is our event loop utilization. And because of that, we can start returning what is called a 503 error. And basically say, no, we are not rendering this. Why? Why we want to error instead of, delaying? Well, because the user gives up after 2-3 seconds. How many people, you start loading a page, it doesn't load, and you go away? So if I can't respond in 1, 2, 3 seconds, I can just give up, okay? There's no point. So I'm just saying, nope, I'm not rendering this at all. And I'm saving CPU time, okay? I'm saving precious CPU resources so that I don't waste them in doing processing that's not needed by anybody. So this 503 status code, what it happens is it has a very specific meaning that you can configure in your load balancer. All of them can do this, essentially. So let's say that we send a GET request to our node process, and the node process says, oh no, I'm busy, 503, okay? What should we get back to our user? Well, we could send back the 503, or we could forward it to another server. And this is a behavior that Nginx and all the others can have behind a config flag, behind an option. It's pretty great. So, and then you can have the answer. You can send back the data, okay? Because maybe the other server is not busy. Now, here's the problem with this approach, which is if somebody can give you a very bad request and can cause a catastrophic failure to all your servers, but look, we are threading the needle here. So it's time for the demo, and because we are in Athens, I put some ancient Greek stuff from Sicily, just because. I took this picture, by the way. Okay, it's demo time. On a battery, on cellular phone, or whatever. So if it doesn't work, okay, let me show you. So this is our typical node server. Okay, it has a Fastify app and with a very simple route. I'm on battery, so in order to simulate the event loop blocking, I'm using this library called Atomic Sleep, which use atomics to actually sleep instead of keeping the CPU busy. So I can block the CPU for right about that without actually having my CPU actually busy. Okay, it's absolutely a fake, but it's good for the show. So this is the system. Okay, now we can run our server. Go well. Okay, so we have our server running. Okay, now we can curl it. Let's see what it says. Okay, hello world. It's working. So what I have here, I'm using a utility called autocannon to run some tests. Okay, I'm running 50 connections for 10 seconds on one thread, more or less. That's what it says. And we are running this. Takes a little bit of time, 10 seconds, I said. So we're running 50. How much requests can 50 connection arriving at the same time to our server? And look, it's pretty bad. Okay. Our server, as I showed you, okay, here, this was blocking for 10 seconds and then 20 seconds. Okay. So we are blocking for 10 seconds here and then blocking for 20 seconds down here. Cool. So, not good. Okay. The big problem is not the amount of requests that competes, are the errors here. It's not about the total number of requests, it's about the errors. Okay, let's fix this. So instead of running my server, I can just run it with a very simple protection. So I'm saying that if the event loop delay is over 200 milliseconds, and if I have an event loop utilization over 80%, I'm just saying no, okay? And returning a 503. So, okay, server protected. Okay, so now we are running it again. Demo gods. In the meanwhile, there's a lot of gods here. Okay, now the numbers are pretty good. We moved from, like, the total number of requests actually went up quite a lot. Okay, we were able to do way more requests than before. Okay, 200s, yeah, we more or less can handle way more than before because we are not wasting any CPU time doing stuff that's not useful. However, though, big problem, we have a lot of file trees. So, can we do something better? Yes, we can. So, okay, here is the gist. We now have a way to know if our server is busy. If we know that our server is busy, we can actually write a route that do different things if the server is busy, okay? And this is one of the greatest techniques that you can play, especially when developing React server-side or server-side render components. Because if you know that your server is busy, you can actually say, oh no, I'm not doing any server-side rendering now. I am saying, oh, but it's my React app. I can render it on the front end and everything is happy. And that's it. That's the gist of it, right? That's the beauty of isomorphic code. I can run the server, I can run the front end. So instead, I can just say, this is never going to be rendered here in time. If this is never going to be rendered on the server in time because the user is going away, there's no point in actually trying to do it. So let's just return an empty HTML to the user, and they load it up on there. If I've done things right and my API is exposed elsewhere, they will never notice. So let's try that. Okay. Let's see. Way better numbers. A lot of requests responded, of course, because we get the actual, we have a very good, we have good latency and the user have a good experience, or not destroyed experience, I would have to say. You're still under, more or less, under an attack, okay? You're still under Black Friday. So, you know, if that's what it is, okay? So you can still respond at least, okay? So let's go back to my slides. Okay, so if you want to check those out, those servers, there's a QR code if you're interested. Okay, I don't know if some people are taking a picture, maybe picture. Yeah, great. Okay, perfect. So, however, we have not finished, because if you have not checked out Node since 2015, when it became extremely popular everywhere, and you probably haven't, because that's what the number tell me, Node.js is now multi-threaded. So instead of blocking the event loop, instead if you need some processing, you cannot just say, oh, look, I'm not doing it. I am running it on another thread. And there is this library called Collina that wraps the Node.js worker threads module that actually allow you to do that. You can just pass an MJ, your file and just run it and get a result. Okay? And so you can avoid blocking the event loop, okay? Because, you have threads. So, now, is multi-threading useful even if you only have one core available? Yes, it is, because now you can actually easily monitor the other thread. So you can have your main thread doing things, and you have your worker threads doing other things, but the main thread can actually watch the secondary thread. So there's no problem of stalling anything. So it's good. Now, what happens if, but we're running multiple requests at the same time, right? On the server. So what happens if we cross them? Like if we need to do the same processing for two different users, why are we not doing it? Why are we doing it twice? We are doing processing multiple requests for multiple users at the same time. Why are we doing it? Well, because everybody tells us to not cross the streams. This was being very much ingrained in my childhood. So, okay, let's take a look. So if we can deduplicate our work, okay, we do HTTPS comes in, and essentially we do all our first synchronous blocks here. We detect it is the same. When we get the response from our database, we just respond to all of them. So we have basically saved a lot of time, a lot of CPU time, a lot of database time, a lot of resources, okay? This is what's called typically a deduplication cache, and here it is. Some time ago, I wrote this tiny module called async cache dedupe that works great. It supports both memory and Redis, so just works. You can just use it. Performance is great. A few big sites are up because of this, so I'm pretty proud of this tiny module. Okay, a couple of things. Work for this startup, Platformatic, do Node. So what we do is we help you move from A to B very fast, but still get you where you need to go, like with a nice SUV, okay? It's pretty cool, and there is, we have our docs, okay, available if you want them. I'm going to do a little bit more of showing you a couple more things, how this works, okay, with a visualization. I didn't want to introduce it earlier. So we have this tool called Meraki in Platformatic. It's a network app that you can use to help you debug things. And let me zoom in, okay? And as you can see here, we can plot memory. So let's try this. So instead of running this, we run it against the other port, which is 3042. First, we're running against a slash, which is the route without any performance, without any sleep. And it's running, can do pretty good numbers here. Okay, now this is what I wanted to show you. So what happens when you do a lot of the stuff? You see this overshoot, okay, of that you can see from a Node app is what I saw, what I was telling about the memory consumption. It's, as you can see, V8 and Node overshoot consumes a lot of memory because it's receiving a spike of traffic, and then it's settled down at a lower level. 10 minutes. Yes, I'm almost done. Great. While we are doing our benchmarking, you can see at the bottom, okay, here, that our event loop utilization went up to and spiked to 100%. So pretty good, right? And here we can, yeah, that's good. Okay, perfect. Now, let's try with the first endpoint, which is the one without, in Platformatic we have, by default, well, you can enable, what is it? We can enable the else check, the under pressure configuration, just enabling the else check, which we have have added it by default. So here we go. So we are here. Okay, we are running the first route. As usual, doing benchmark on stage, on a battery, on whatever. Okay. Condition is what it is. Okay. Now, as we can see, we get a lot of 503s. So the protection is actually working and so on. So our process become responsive, latency is good. And here you can see what's happening. And you can see that we have a big spike in latency now. Okay, this is the latency, we got big spikes, good. And also here we have, this is not good, right? Super blocking. So let's try the other route, which is the one with the load-aware protection. And again, okay, so it's pretty good, and we can get auto responses here, and now everything works way better, okay, because we can actually respond to things. So I just wanted to show you all of this stuff and how it was playing out, okay, and look, this is, again, this is Sicily still, I keep joking with you, okay, and yeah, thank you very much.
Thank you so much. Let's give it up for Matteo one more time.
Yeah.
Matteo, Collina.
Yeah, absolutely. Are we doing Q&A or are we not doing Q&A?
I don't know if we are doing Q&A. We are doing a Q&A. So let's see if you have any questions in the room. Wherever you are, you put your hand up. I'm going to try and find you. I'm going to do a little